All right, everyone, welcome back. So now that we looked at equivalent fractions, we can do a few examples that involve cross multiplication, also finding equivalent fractions and verifying if two fractions are equivalent. Remember, try these problems out on your own before you see the solution, and even after you see the solution, try to do them again on your own for practice. So let's go with the first one. So let's see, we have, is 2/3 equivalent to 12/18? So 2/3, is that equivalent to 12/18? Remember, there's several ways to check this. If you can find a number that you can multiply or divide both the numerator and denominator by, then they are considered equivalent. So let's see, 2 times a number, well, that gives me 12, that'll be times 6. And 3 times a number, that gives me 18 times 6. Notice that these two numbers do match. So they are equivalent. You can also draw a picture, but drawing a picture might not be the best way to go about it, just because you might have to draw very tiny parts, right? 18 and then shade 12. There's a chance that you might not draw it accurately. The other way to do this, if you recall, is cross multiplication. So 2/3, 12/18. You create, this only works with proportions when you have a fraction equal to another fraction. So you circle two other items. The things that you circle are things that you're going to multiply. The same thing here. So now we get 2 times 18, that is 2 times 18 equals, right, bring down the equal sign. And then on the right side is 3 times 12. So that's going to be 3 times 12. Now 2 times 18, that is going to be 36. And on the right side, we have 3 times 12, which is also 36. So they are equivalent, right? In both cases, they are equivalent. Next one says, is 3/4 equivalent to 9/16? Once again, we can either find a number that we can multiply both the numerator and the denominator by, or you can also divide. Remember, you can divide. Dividing is a possibility. But if we look at 3 becomes 9. I mean, if we look at 9 becomes a 3 if we divide by 3. And then 16 becomes a 4 if we divide by 4. So in this case, we can tell that they are not equivalent, because on the top we divided by 3 and the bottom we divided by 4. The only way they would be equivalent if we divide by the same number. Now let's say we use cross multiplication. If we would have attempted to use cross multiplication, then we would have got a 9/16. We multiply these two. So that's 3 times 16. Bring down the equal sign. And we also circle the 9 and the 4. So 4 times 9. On the left side, we are going to get, let's see, that's 8, carry the 1, that's 48. And on the right side, we're going to get 36. So as you can tell, 48 is not equal to 36. We got a false statement. Therefore, these are not equivalent. So they are not equivalent. So we can say 3/4 is not equivalent to 9/16, right? Not equivalent. They are not a proportion. All right, so keep practicing that. Try your own. Look at past videos for more examples if you feel like you still need to practice a bit more. Go on with the next examples. Other types of problems you might come across that have to do with equivalent fractions. Here we're given 2/3 and then there's a missing number. If we look at the instruction, it says what is the missing value that would make the two fractions equivalent? So what number needs to go here that will make these equivalent? Right, so we are given some information that we can use to help us find an equivalent fraction. Remember, equivalent fractions are just fractions that represent the same data or same information, except that they look different. We know, for example, that we can find an equivalent fraction if we multiply the numerator and the denominator by the same number. In this case, 3 times some number that gives us 6 will be 2. So if we multiply the top one also by 2, that should give us an equivalent fraction. If we multiply the top one by 2, that will give us 4. So 2/3 is equivalent to 4/6. So these two are equivalent, right? You can use multiplication to find them. On to the next one. We have 14/70 is equal to 10, to a number over 10. Once again, we're given some information that we can kind of figure out what we're supposed to have. So a 70 becomes a 10. We have to think about it using multiplication or division. How does a 70 become a 10? In this case, if we divide by 7. So if we divide the numerator by 7, we have to divide the numerator by 7. We have to divide the denominator by 7, and that will give us an equivalent fraction. So if I divide this one by 7, this will be a 2. So 2/10 and 14/70 are equivalent. Let's look at the next one. On the next one, I think I made a mistake. There should have been a 6. All right. So 6. So let's see. So there's two ways to look at it. You can either say, well, 6 times a number, right? Because the only way a small number becomes a bigger number is through multiplication. So 6 times 5 will give you 30. So 6 times a number, 3 times 5 will also give 15. So you have 15 over 30. Those two are equivalent. There's lots of ways to do math. You can also actually go the other way. Like if you say, well, how does a 30 become a 6? Well, you have to divide by 5. So you have to think of a number that you can divide by 5 that will give you 3. And it's 15. So either way, you get the same answer. Sometimes it's easier in one direction than the other. I actually prefer the multiplication. But if division is how you see it, then that's fine as well. So once again, to find equivalent fractions, just multiply the numerator and denominator by the same number. In this case, we're given only one of the numbers, but that we know that if we multiply the numerator and denominator by the same number, we should get an equivalent fraction. And last example says, find 4 fractions that are equivalent to 1/2. As mentioned before, you can multiply the fraction by any number you want and you'll get an equivalent fraction. So as long as you multiply the numerator and the denominator by the same number. So we can say, okay, I'm going to multiply this times, 10. So if I multiply the denominator by 10, I multiply the numerator by 10. So I get 10, 20. So that's an equivalent fraction. Let's go with, once again, 1/2. Let's say we're going to multiply by 3. So that'll be 6 times 3. That'll be 3. So 3/6 is an equivalent fraction to 1/2. And let's see, they want 4 of them. So let's see, 1/2. We can multiply by, 100. So 100 over 200 is equivalent to 1/2. Let's make the last one a little bit more challenging. Let's divide by 2. 2 divided by 2 is 1. But if I divide the denominator by 2, I have to divide the numerator by 2. So 1 divided by 2, that is 0.5. Or you can also say 1/2 over 1. All right, we'll get into that later on. But just remember, to find other equivalent fractions, you just have to multiply the numerator and the denominator by the same number, and also divide the numerator and denominator by the same number. And that should reproduce, or that should give you a new equivalent fraction. So in this case, 1/2 is equivalent to 10 over 20, 3 over 6. All these are equal. Like, you can take any of these and replace them with any of the other ones. So if you don't want to use 1/2, you can use 3/6. If you don't want to use 100 over 200, you can use 1/2. All of these mean the same thing. All of these mean the same thing. They're all equal to each other, all equivalent. So I think that pretty much wraps up equivalent fractions. Next, we'll be talking about reducing fractions and simplifying fractions. Again, if this helped out, please subscribe and give the video a like, and I'll see you next time.